In previous video, we have seen what is caster, what is camber, and we have also seen kingpin inclination. Now we will see what is toe in and toe out. When you are looking from the top of the vehicle, you will find that the front wheels are closer as compared to rear side of the wheel. Then this type of the wheel's position is called as toe in. Okay, just we will see the definition which has written in book. The toe in is the amount in which the front wheels are set closer together at the front than at the rear when the vehicle is stationary. Okay, how you are going to calculate this toe in? The outer distance, this distance divided by this distance. Okay, then it is called as toe in. Okay, so just we will see a small amount of toe in will make a car more stable on a road, but just a bit less responsive turning into the corners, but it will not help this toe in when turning a vehicle. Okay, and the car has a toe in, it means that the front edges of the wheels are closer to the each other than the rear edges. Okay, and you have to measure that distance should not exceed 3 mm. Okay, always remember this toe in distance should not exceed 3 mm. Now we will see what is the effect of this toe in. Due to this toe in, there is decreased oversteer and increased directional stability. At high speed it can be achieved. And now we will see the toe out. What will be the toe out is exactly opposite to this toe in. The front side of the wheel are at a larger distance as compared to the inner or rear edge of these wheels. Okay, just see toe out. Toe out describes the setting of pair of wheels on the axle in which the edges of the wheel is inclined slightly outwards. Slightly outwards. These edges are inclined slightly outwards. Then it is called as toe out. This increase in toe out would result in reduced understeer and greater ease in steering during cornering. Okay, means during cornering it steer toe out will help. Okay, so this is about toe in and toe out. Okay, now we will see the what is just before going to the next point. Once again we will see what we have learned during this lecture. We have started with steering ratio. What is steering ratio, how it helps, as well as we have seen different angles, definitions, camber, caster, kingpin inclination, included angle, toe in, toe out. Okay, we have seen camber, what is the effect of camber and how it increases the life of the tire. What is caster? It will helps in the road stability or increasing the performance of the vehicle. We have seen positive caster, negative caster, as well as kingpin inclination, which helps to straight ahead recovery or directional stability. Then we have seen the toe in, toe out. Okay, what is toe in and toe out? And now we will see the important one of the important thing, the conditions for the correct steering. Okay, for the correct steering represents a condition in which all the four wheels of the vehicle undergo rolling motion without slipping while the vehicle is in motion. Means when the vehicle is on the road and moving, at that time it should not slip, okay, without rolling motion, undergo rolling motion without slipping. It should turn or it should correct steering. Okay, and when it's happen, there is some conditions. Okay, when the vehicle is turning, the inner front wheel should have higher degree with compared to the outer wheel. Okay, here this is the center O, or this center is called as instantaneous center. The axis, rear axis or axis, passing through the rear axis as well as through this point, all the axis, all the wheels axis passing through this point is called as instantaneous center, and it will rotate along these points. Okay, for that purpose there should be to correct steering, it requires some mathematical equation. It should satisfy some mathematical equation, then only we will get the correct steering. Just we will see how we obtain that conditions. First, this is the length of the wheel base. Okay, this is the length of the wheel base, and this is the width track. Okay, width track B to C, it is shown by W1, and this is length is shown by capital L. Now this outer angle is phi. Okay, passing through this point D, O, and this rear axle, this angle is phi, and inner angle is theta, K O B. Okay, this is theta. When the axis meets at O, this is called as instantaneous center. Now we calculate tan theta, inner angle, capital L upon this distance. Okay, outer distance O to B. Okay, just we will see tan theta. Okay, tan theta, I think this angle is at inner wheel angle is theta, inner wheel, this is the inner wheel, this angle is theta, and this outer wheel angle is phi, outer wheel angle is phi. Now we will calculate tan theta means outer inner wheel. Okay, this distance is L upon CO. This horizontal, you have to consider this triangle ODC. This triangle you have to consider while calculating tan theta. Okay, the front side and adjacent side. Okay, you have to don't consider hypothesis. Okay, now we will calculate tan phi outer wheel. Okay, this distance length upon this triangle you have to consider OKB. Okay, length, this side divided by this side BO, L upon BO. You have to consider this triangle, you will calculate tan phi. Now similarly, if we take a reverse, okay, then you will get cot theta. Cot theta is equal to CO upon L. Cot phi is equal to BO upon L. Here you will get exactly inverse. Okay, exactly inverse. Okay, tan theta inverse is cot theta, tan phi is inverse is cot phi. When we calculated cot phi minus cot theta is equal to this BOL minus CO upon L, BO upon L minus CO upon L. You will get the denominator is same, capital L or length, BO minus CO. Here you will get BO minus CO. You will obtain W. Okay, this will be the condition for the steering. Cot phi minus cot theta is equal to W, or we can say V track width divided by V length of the wheel base length. Okay, distance between the front axle and the rear axle. This is the length. Okay, and we calculate W upon L is equal to cot theta minus cot phi minus cot theta. These distance are fixed. Okay, these we cannot change. Okay, once the vehicle is built, but we can, on this basis we can calculate angle theta and phi. Okay, always remember this inner angle should be always greater than the outer angle. Okay, and this is the condition for the correct steering. Okay, correct steering. I think you understood better. Generally this correct steering angle is 44 degree. Okay, this maximum angle for the inner side is 44 degree. Above it, above 44 degree it is not possible, or it makes it difficult. It will steer the these conditions will not satisfy. Okay, so on the basis of this width of the wheelbase and length of the wheelbase, the theta and phi is calculated. Okay, so in today's lecture, in this video I have covered what is toe in, toe out, and what is steering, correct steering. Okay, now I will stop here.